What's up, Clarity Coders and guests? In today's video, I'm going to show you how to train a YOLO-based network to play a simple and silly game called Toadled. Now, you've seen these networks before do object detections and important tasks. We're going to show you how to do that in a fun way, but you can train it to do anything you would like. This game is pretty simple. We're going to detect objects and use PyAutoGUI to click on those objects to score points. At the end of this, you'll know how to train your own custom network, and as always, you have full access to my code below. Let's not waste any more time and jump right in. Now, the first thing we need to do here is create a folder to hold our images. We're going to have to get some images so we can tell our network what's a bug and what's a bomb. We'll create a virtual environment, and I'll install my libraries here. And then finally, we'll run it. Now, if it works, we'll start filling up images in this image data folder here. Perfect. And if we look at one, you'll see it's my other screen. Great. So now we're going to be able to view the total game and take pictures while we play it. I'm going to increase the sleep time to 1 because I want the images to kind of be different. Now we'll open up the game. All right. Now let's play. Let's just do a little proof of concepts. Let's go stage select, and we'll just select stage 1. You'll see why here, because training these networks is kind of terrible. So if this doesn't work, I don't want to do. Oh gosh, slow mode. We don't want that. All right, so you can see our script is taking images right now, and we'll be able to use that to train later. So I'm just going to play this game for a bit and generate some training data. Now, eventually, the other levels have different enemies in it, so we're going to have to train on that as well. But this will give us a good feel for if this is going to work or not. I don't know if it's going to work because of the CPU. So we're going to use a CPU instead of a GPU. That way, anybody could run this. In theory, anybody could run this and be fairly successful. All right, so we're done getting our image data. We're going to roboflow.com. This is what we're going to use to annotate our images. Now, each image has to have 4 corners to show where the item is you're looking for. So in our case, we're looking for bug or bomb. Roboflow makes that process really easy. So we're going to create a new project. You can call it, well, we need a project type first. It's an object detection. You can call it whatever you would like. This is also free as long as it's a public data set. So you'll be able to view my data set and not have to annotate all these images, which you'll see is quite the process. Okay, so we got our project set up. Now we can upload our images. So I'm going to drag that entire image data folder into this section here. Now I'm not super familiar with this process, so bear with me here. We'll let those upload. Okay, now we got them here. So now we can start annotating our images. So I'm going to click into one. So we have no classes right now. So we're going to highlight something, and then we're going to tell our network what it is. So the only thing I'm really interested is maybe the buttons, maybe the bombs, and then the bugs. I'm going to draw a box around the bug. You can call the class whatever you want. So you can imagine if you're doing it on a different project, I'll just call it bug and I'll hit save. Yeah, we should be good there. So now we can do this for all of our images. Like I said, it's a bit of a process here, and I'm going to speed it up a little bit for you guys so you don't have to watch me annotate hundreds of images. But you need this training data in order to teach your neural network how to identify objects. Now, you can use YOLO standard if you're doing like people or something like that that's already been trained, but because ours is unique, you're going to have to train the data yourself. So if you're in your project where you're doing something unique, you're going to have to train it yourself. As you can see, I've gotten through like 2 images here in the 30 seconds of me rambling on. Save one more. All right, one more, and then we're gonna call it a day, and we will come in fresh tomorrow and annotate through the rest of these images. I won't make you guys watch that. All right, loading back up Roboflow, fresh day here. We're going to annotate these images. We'll click into our total project. Oh, good Lord. No! No! Where the hell are all my images? After I cut last night, I annotated like 100 of the 300 or so. And now it looks like there's nothing in my project. Okay. No! Okay. Okay. This is okay. Okay. Let's upload our data again here. Fast forward. Ah, I got it. So, just for everyone's reference out there, definitely hit the save and continue button before you annotate your images, or else they might disappear. This makes more sense. I'm on Canon shoestring internet, and I wondered why the upload time was so quick. So we will let this upload and then annotate the images, and then I'll show you how you can start training your network. All right, now that our upload actually was successful, it asks you to assign. So I'm going to assign these images to myself since no one wanted to help me annotate these images. Join the Discord if you do want to help me with different projects and different things like that. I would certainly love to have split up this horrific process here. And now let's crank through these images. All right, now that process is complete, we can hit add images to data set. It gives you a nice split between training, validation, and testing. If you're not familiar with AI in general, you usually have a validation and a testing set to make sure you're not overtraining your network. We can browse our data set here, and you can see what's in each, and then we can click generate, and this is where we'll actually create our data set. Now they have some awesome options to resize your images, which we don't really need to do, so we'll delete that out. And you can also perform augmentation, so you can add noise to your images and effectively create more images than you actually have. So a image of a frog with a bomb on the screen, you can add a little noise, or you can rotate it a little bit and make it a slightly different image. Once that's all done, we can hit generate at the bottom, and then you'll see it creates our data set for us. Now it's going to host this data set, and we're going to connect it to Google Colab, where we can use a free GPU to train our network. Now you can actually start training here. I've never done this, but it's a different model than we want to utilize, so I'm going to skip over that. We'll just hit this export button, and then you'll see here that we can just show the download code, and we want to make sure we're picking Yolov7 PyTorch, and then we can hit continue. It'll zip your files, and then it'll give you the actual code you need. Now what you're going to do is you're going to open the Colab notebook down in the description, and then you're going to paste in this information. Now it has an API key that I'm going to kill, so don't copy mine. You have to use your own, but you're going to just copy this code and then paste it into the notebook. I got a copy of the notebook up here. We're going to run through all these cells. If you've never used the Jupyter Notebook, you can just click in the cell and shift enter, and it will run the cell. So it's going to download some libraries we need and some different things like that. We'll just make sure it starts training. You can tell by all the red, this is not very successful. Let's see what happened. Scroll up, punch code. You'll see for whatever reason it didn't get the version here. So let's just copy this again. We'll paste it back in here. Now it has the version. Yes. Shift enter. We can run that again. And we'll just make sure this starts training. Great. Now this process is going to take a long time. Now you'll notice also I added a Yolov7 Tiny as the weight. So this is going to be a fairly small model, which means we'll be able to make decisions very quickly, but they might not be as accurate as a bigger model. I think this is a fairly simplistic task, so I'm not overly concerned with a super deep model, and I'm interested in you being able to run it on your CPU, so I'm going to make it as small as possible. All right, we'll let this train, and we'll come back and show you how to grab the weights. All right, now my training is complete. I'm going to open the Yolov7 folder. I'm going to click in the runs folder, and then train, exp, weights, and there's a best.pt weight. I'm going to download that. That's going to be the weights that have actually been trained to identify our objects. You can download the bit of code from my GitHub, but I have created a screendetect.py. So what it's going to do is it's going to take screenshots of the screen, and then it's going to draw a rectangle around our objects. You'll see it starts up. Now I have a key that I press to start it, just holding down S with the keyboard library. And look, it works. Sorta. The colors are all messed up. Now this is kind of interesting. So most models, PyTorch models, take the colors in a different order. So, you know, most images are set as RGB, red, green, and blue, but you'll pass it into the PyTorch model as a different color scheme, so then when you bring it back out, you got to convert it back. So I will fix that in the code that you can download below. But the good news is this is working. So let's make a couple quick changes to our detection, get the mouse moving, and then we'll be able to try it on level 1. I'll see you there. All right, we're booting up level 1 here. So now it is fully automated. So what I did is I got the color scheme fixed. I drew a bounding box around it, which you can see. And I also printed out the label class as well as the percentage, the detection percentage. So essentially what it's doing is it's showing you how sure it is that this is what it thinks it is. Now, I've decided the limit of drawing the bounding box. I set the bounding box as like 82 or 3. So if it thinks something is a bug at 70%, it's not going to click on it, and it's not going to draw the bounding box. Now, everything looks like it's going pretty well here, and you can see that it does identify everything correctly. So we're just going to let this run. I'll speed up a little bit and we'll see how it does. And then we'll go on to the next levels and we'll annotate the whole thing and we'll see if we can get the high score or beat my human score from there. Oh, I was so proud of it. It got achievements. It got pretty far. Now you'll notice we're not moving on to a next level or anything like that. And it does eat a bomb in the end because it thinks it's a bug. But other than that, fairly successful. As you can imagine, my life is about to get a lot rougher. Yes. Oh, good Lord. We're back here. So it moves on, and in the game you start eating people, tanks, all kinds of things. And we are going to scream through this annotation. Yes, annotate, annotate, annotate. It's gonna blow your mind how many images I had to do for this project at the end. So we'll continue annotating our images, and then we will hop in and try again. So what we're going to do now is we're going to try and get through level 8, see if there are any issues, and then we'll do the end game, which is the last couple levels. All right, now that we're done, we're gonna have to generate our database again. We're going to have to train again. I'm not gonna show you that, you've already seen it. You can see we have more images now. Let's go ahead and watch our run in the real game. Now, I don't know if you took note before, but you can see that our percentages are a little more certain. That's certainly because of the amount of training data we had, so it's very defined what's a bug and what's not. And you'll see now we're moving on to the next level, so we'll get new objects, which we have trained on. You will notice, however, when objects move or turn, and look, that bunny, it didn't notice it at all until it got close to the frog. So it is still not perfect. It is still not identifying the objects perfect. Now, one thing we could do is turn down the limit of a detection, right? Right now it's set at 82. We could turn that down to 70. And that would probably help. But we run into an issue then. We'd probably start eating more bombs because it would think it was food or vice versa. So we don't really want to do that. We might just want to train more. You'll notice too, when we got that squirrel, it threw its hair and then it thought that was a bug as well. So we're getting better, but we're not quite there. There we go. Okay, it's not terrible. Still taking hits, but it's not horrific. So what we're gonna do is we're gonna watch this run. We'll speed it up a little bit, and then we'll see what we need to train in order to beat the game. Now, I'm actually really proud of how far it got, but you'll look, I'm kind of going normal speed here again to show you guys. You'll see it thinks its own image down below is food. So what we need to do is we need to add some of those images in and then train it that that is not food in the bottom edge there, and that will help us. But you'll notice that's distracting us because it keeps licking down there as opposed to our other. All right, now I'm in Photoshop. We're gonna do something a little different. So one thing I did was I brought in images that I knew our bot did poorly with. So the images that it ate a bomb, or the images where it's licking itself in the bottom corner, or whatever it might be. So we're gonna bring those in. We're gonna create new images, we're gonna upload, and then we're gonna train it on those as well. Now, after all the photoshopping, you can imagine, oh dear Lord, we're back to annotating. Annotating images. All right, so our final gameplay here. See if we can actually do it, how far we get. You can tell it really jumps ahead. We only got 2 bugs that time before moving on to the next level. Notice our detection is pretty good. I actually lowered the detection to like 78 as well, just to help out. Now that it really knows the difference between bombs and bugs, I don't think that should be an issue. We're jumping right ahead. Getting to the next level. We're clicking. We use PyAutoGUI to do our clicks. So if you're doing a similar project, that's a good library to use. MSS for our screenshots because it's faster than PyAutoGUI. So that's why I do that. We're already on to mountains. Doing a good job with those detection-wise now. Planets. We got our aliens. Okay, this is where our CPU probably lacks. We can make faster decisions, faster clicks with a GPU. But again, pretty impressive to run through a YOLO network like this. And we got our new high score. They beat my high score already, so that's cool. And we did make it to the last level. Now we moved on to the survival. You'll see my high score on the screen here. It actually keeps playing, so it's probably not gonna stop. It's probably gonna complete this and just rock and roll again. But I'll show you the high score here. If you want us to do any other games, let me know in the comments what you would like to see. And until next time, keep coding.